Hello, and welcome to a video lesson on CPCTC. Okay, so we're going to be talking about proofs involving CPCTC, and I'm going to say that fast and I apologize. So yes, last time we talked about two-column proofs where we proved two triangles are congruent, and now we're going to talk about proving that their corresponding parts are also congruent. So CPCTC stands for corresponding parts of congruent triangles are congruent. And that's a lot, so let me put that into some terms that we can visualize. So for example, it's like saying the engine of a 2019 Tesla is going to be the same as an engine in another 2019 Tesla. Okay, Tesla's not going to make two different Tesla cars and have them have different parts. Like, that's not making sense for them. Okay, if you wear earrings, like I have some Disney earrings down here. Okay, it's like saying your left earring is going to be the same as the right earring. Okay, companies aren't going to make two different earrings. They're going to replicate the same thing and it be the same. A 12-pack of Coca-Cola bought in Tennessee is going to be the exact same as a 12-pack of Coca-Cola bought in any other state. Okay, as long as you know you don't get cherry Coke or something. It's going to be the same ingredients, everything, just depending on where it's made doesn't change the product. And last but not least, Ariana Grande just came out with a new album. Okay. So buying her album at Target is going to be the same as buying it at Walmart. The order of the songs are not going to change. They're going to be in the same order. It's the same songs by the same artist, okay? So that, what CPCTC is saying, if you have two things that are the same, then all their parts are going to be the same as well. All right, so let's talk about how that fits with geometry. So we talked about bridges in the past and how triangles were the strongest shape and are used in construction in many instances. And so bridges are an example of congruent triangles. Okay, so here's a cable bridge. You've got cables strung from a tower. You can see in the smaller diagrams, the cables are going to balance the weight of the road. Okay, so that makes the bridge stable on both sides. So let's take a look at some of these bridges. We have mono, harp, fan, and a star bridge. And so what do you notice about the opposite sides of the towers? So what do you notice about this versus this? Well, you know about the left side versus the right side. Hopefully you were thinking they're the same. Okay, so this triangle on this side is like a reflection. It's the exact same thing on this side. Okay, they're congruent, they're the same. So all of their angles are going to match up, and then all of their sides are going to match up. So this length is going to be the same as this length. This angle is going to be the same as this angle to kind of balance everything out. So you've got the same tension on both sides, so your bridge is going to stay flat and the bridge won't collapse. Cool? Okay, so that is how congruent triangles are important in the real world, and now we're going to talk about them in geometry. So let's talk about two triangles. I've got triangle ABC over here, and I have triangle DEF. We know from previous lessons, are these triangles congruent? We know they are, because I need three pieces of information, combinations of angle sides to prove they're congruent. And so this is going to be our side angle side congruence theorem. So yes, by side angle side. Okay, so those two triangles are the exact same. They have all the same pieces, all the same sides. So what that tells me, CPCTC, I already know A and D are the same, they have a mark. I already know A and B and D and E are the same, they have a mark. I already know AC is congruent to DF, they have a mark. But if I know they're congruent, I know the other three missing pieces of information is also the same. So for example, I know B and E, they're in corresponding parts of congruent triangles, so they have to be congruent. So I know that angle B has to be congruent to angle E by CPCTC. It's a part in congruent triangles, so they have to be the same. The other corresponding part, or angle in this case, is going to be C and F. C matches up with F, it's its corresponding part. So I also know that angle C has to be congruent to F, because they're congruent triangles, so all the corresponding parts match up. Okay, there's one more piece of information I don't know, and it's a side in this case. So the side is going to be, for example, BC. I know that BC has to be congruent to EF. Okay, so if you know two triangles are congruent, then you know all the angles match up, and you know all the sides match up. You just have to find their corresponding positions. Okay, and you should be able to tell three pieces of information that is congruent, because they mark three, and then you can deduce three. okay? All right, that is CPCTC in triangles. So let's look at proofs. All right, we have a proof on the left and we have a proof on the right. And hopefully you realize, it's the same picture, okay? So what I want you to do is I want you to look at the proof on the left, which is what we did last week. And I want you to look at the proof on the right, which is what we're learning today. And I want you to compare and contrast and jot some stuff down. So what is similar? What is different? If you want to circle some things and be like, this is similar, this is different, go for it. If you want to highlight some things, if you want to draw some arrows, but ultimately write a few sentences down. What's the same? What's the different? What do you notice? Okay, press pause and then we'll discuss. Press pause. So let's discuss what we got. So I said how they're different is in the last step of the proof part is different. So what that means is I was proving two triangles are congruent last week, and now I'm going to be proving some angles are congruent, okay? So the proof part was different. Again, the proof part was still the last part, but it was a different proof. It wasn't the triangle this time. For the similarities, they're the exact same proof except the last step. So lines 1, 2, 3, 4, and 5 are the exact same as 1, 2, 3, 4, and 5 over here. Again, you have the same givens, it's the same picture, etc. Okay, so CPCTC is not anything super challenging. It's one extra step in your proof. That's it. Okay. The good news is they tell you the last step, so you really don't have to do a ton of thinking. It's just one extra step. CPCTC is proving angles or sides. So it's either going to be naming an angle here, it could be naming a side. And then what will always happen, the triangle part has to come right before the CPCTC part, okay? So for CPCTC, it is corresponding parts of congruent triangles, so you first have to prove the triangles are congruent, okay? So basically you do every single thing you did last week, but then your last step is once the two triangles are congruent, then you know all the angles and sides are. And that's it, okay? So let's take a look at an example problem. All right, so we've seen this proof before, but we're just going to try it again, and we're going to do a CPCTC this time. So the reason I know it's a CPCTC problem is they don't tell me to prove the two triangles are congruent. They want me to prove a side this time. So I am going to go ahead and put that in the bottom one. And I know it's CPCTC. Corresponding parts of congruent triangles are congruent. Okay? And then we're going to work on this. So I'm going to stand up. So AC bisects DE is a given. And then our other given is angle A is congruent to angle C. Okay, I'm going to make some marks in my picture. AC bisects DE, I'm going to skip that for now. They do tell me that A is the same as C, so I'm going to mark that. All right, I do not mark the proof part. So now I have to make some marks. So I see vertical angles from Module 1. So I'm going to say vertical angles are congruent. I'm going to abbreviate. Vertical angles congruent. Now I have to name angle B in the same way. So I'm going to say ABD. I'm going to start at the green mark and then go to the blue mark and then go to the no mark. Is congruent to, if I started at A, I have to start at C. So CBE. Okay? So now my vertical angles are congruent. Now I have to go back to what they gave me, and they told me AC bisects DE. So it's a segment bisector because segments are two letters. So I'm going to have to be cutting a segment in half. AC is the scissor. So here is the scissor, and it's going to cut in half DE. So I have to make a mark on DE. So I would say DB and EB because DE has to get cut in half. So this is the one that gets marked. It's the second one. Okay, so now I just have to name that. I'm going to say DB, start on the outside, is congruent to EB. Again, start on the outside, go to the inside. Keyword there is bisect, so I'm going to say definition of a bisector. Okay, so now I have one piece of information, two pieces of information, and three marks. Okay, so now I can prove my two triangles are congruent. If I look at my picture, I have a side and then an angle and then a side, or no I don't, I have an angle, angle, side. And in this triangle, I also have an angle, and a side. So angle, angle, side is our congruence criteria. And now I have to name my triangle, and there are 6 ways, or 3 ways to do this, and you just get to be consistent. A shortcut is if you already did the work on the vertical angles problem, I can just recopy and paste that and put triangles instead because I know I matched up my letters. If you want to do more work and switch it around, you can. For example, you can dab triangle DAB and EBC, but I'm going to keep it easy and copy and paste my vertical angle one. ABD is congruent to triangle CBE, and then I'm done. Okay, so it's like very much like a puzzle. CPCTC is not, it's just one extra step, and it's not a lot of thinking involved. All the thinking is involved in the proof part, which we've been working on for a few days. Okay, all right, you're going to try one now, and then we'll go over it. So let me know if you have any questions on this one, and I will gladly help you. But I want you to try this top part proof, and then I want you to try this bottom question. Now, before you try this problem, notice there is no proof part. So I kind of want you to figure out what you want to prove. So for example, they gave you 2 sides, so I'm allowed to prove some angles, or I'm allowed to prove some sides. So for example, they told me AC, so I'm going to mark it. AC is the same as EC, and they told me BC is the same as DC. Okay? Now, if I'm trying to think of what to write in my proof part, it's not going to be vertical angles because I know that's already true. But I could maybe prove that this angle A is congruent to this angle E, because that's a corresponding part. Or I could maybe prove that B is the same as D. That would be another example. Or your last side, you could prove that AB is the same as ED. Okay? So again, any of the angles or sides that we don't know can be in your proof part. So for this example, I want you to prove that A is congruent to E. Okay? So press pause and try the rest of the page. Let's take a look at our example. So 1 and 2 are just your givens. Proof part should always come bottom. It will always be CPCTC for an angle or a side. So I really just had to work on my 3s and my 4s. So I have vertical angles. Now you could have named them differently on your paper. I said A, then C, then B is what's equal to ECD. You could have had it flipped. You could have said BCA is congruent to DCE. Okay? Same thing on the triangle. There are multiple ways to write this. Again, the shortcut is if you did the work on the vertical angles, go ahead and copy and paste that and add triangles this time. So I said triangle ACB is congruent to triangle ECD. You could have said ABC, EDC, or you could have said CBA, CDE. Again, lots of answers. The reason will be side angle side, and then that's it. Okay? So remember, right above your proof part, you're going to have your triangle part. So I went ahead and wrote triangle blah, blah, blah was congruent to triangle blah, 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 because I knew that had to go before it. And again, all your theorems, so side, 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 angle, 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 side, hypotenuse, leg, those are always going to go right before CPCTC. Always, always, always. Okay? All right, let me know if you have any questions on that CPCTC proof part. The answer to the bottom one was B. And so they really didn't give you a ton of information, but they wanted you to figure out what the proof part would be. And if it is CPCTC, it has to be a corresponding part. So ultimately, you're just trying to see what matched up. So ST are the last 2 letters, so it should have matched up with YZ, but it did not. T and Z are the last letters, so they matched up, so they're corresponding parts, so I could prove that. Okay? And then again, C and D don't make any sense because I have to prove angles or sides, and C is not an angle or a side, it's parallel. and CPCTC does not prove right angles. It would just prove either angles congruent or sides congruent. Okay? All right, so hopefully you can now write two-column proofs proving CPCTC, which stands for corresponding parts of congruent triangles are congruent. Okay? So if you have two of the same things, then all of their parts are going to match up. Okay? Get to practicing and let me know if you have any questions.